Hello, welcome. So I will be giving you another example in graphing exponential functions. Suppose the problem is, or the question is f of x equals, let's say, negative 5 times 3, what number? Let's say negative 2 times, x plus 2, let's say plus 5. Okay, so before we graph that, let us just try to remember the basic graph of that function. Okay, that's the basic graph, and this is, let's say, at 0, 1. We know that this is your asymptote at y equals 0. Okay, so the first thing that you can remember that you can do here is to graph the asymptote, which is at y equals 5, because that's your d value. Okay, so let's make a nice xy plane, x-axis, this is your y-axis. Okay, so we identify the asymptote. This is your asymptote. Don't forget to graph this. This is y equals 5. Okay, so the question here is, where will the graph lie? Will it be above y equals 5 or below y equals 5? You can determine that by identifying your a value, which is negative 5. Since it's negative, so therefore the graph will be confined below y equals 5. So therefore, we can have x and y intercepts. Okay, so let's first try finding the y-intercept. Okay, so we know that to find the y-intercept, we just need to let x be equal to 0, right? So y equals negative 5 times 3 to the negative 2 times 0 plus 2 plus 5. Okay, so y equals negative 5 times 3 to the, this is 0 plus 2 is 2 times negative 2 is negative 4 plus 5 equals negative 5 times, okay, so we first express 3 to the negative 4 such that it becomes positive. I mean, the exponent becomes positive, and we can have 1 over 3 to the positive 4, okay, plus 5. Okay, so what we can have here is negative 5 times 1 over 3 times 3, 9 times 9 equals 81. Okay, plus 5. And we can have, we multiply negative 5 times 1 over 81. So we have negative 5 over 81 plus 5. In here, you can now use your calculator, or if you want to answer it manually, you can multiply first 81 by 5. That's 405. And then subtract 5. And that's 400. Okay? So 400 over 81. So what is the value of this in decimal form? Let's just try to divide that. 400 divided by 81, and you will get, okay, approximately 4.938. Okay, 4.938. Let's say it's gonna be here, for example. Okay, so that's your y-intercept. What about your x-intercept? Okay, to find the x-intercept, we set y be equal to 0. Let's use blue. So 0 equals negative 5 times 3 to the negative 2 times x plus 2 plus 5. So what we can do here first is we subtract by negative 5. Let's use red. Okay, minus 5 and then minus 5. So we have negative 5 equals negative 5 times 3 to the negative 2 times x plus 2. And we can divide by negative 5. Okay, so this will be cancelled. So this is 1 and this is 3 to the negative 2 times x plus 2. So here we want to express 1 such that the base is equal to 3. But how can we do that? So let's try to recall that in any number raised to 0, the answer is equal to 1 for as long as a is not equal to 0. Okay, so in this case, 1 can be expressed as 3 to the 0. Okay, so we have 3 raised to negative 2 times x plus 2. So we discussed already that if they have the same base, we can cancel it out, right? Using one-to-one property. So we have 0 equals negative 2 times x plus 2. Okay, so what I can do here is I can divide first by negative 2. Or if you want, you can distribute that, but my way is I wanted to divide it now. So what is left is 0 over negative 2 is 0 equals x plus 2. So x is equal to negative 2. Let's say this is at negative 2. There. So the graph would look like, nice one, nice graph. Okay. There. So this is at 0.0 400 over 81. And this is at negative 20. Okay. Okay, the next here is where will 0.01 go? Because it has to be transformed, right? So let's first discuss the the x-coordinate 0. Let's use another color. Okay, so the x-coordinate 0. Okay, so what can we do here is we can multiply that by negative 2? No. So since that is a horizontal shrink, we multiply that by its reciprocal. And the reciprocal of negative 2 is negative 1/2. Okay. What else? We can... So that is plus 2. So that means there will be a horizontal shift to the left 2 units. So therefore, we have to subtract it. Okay, so that is equal to 0 minus 2 equals negative 2. So same as your x-intercept. Okay, so let's verify. So that's for your x-coordinate. What about your y-coordinate? It's 1, right? So 1 times, what we can do here is we can multiply by negative 5 and then we add 5. Okay, so that is equal to negative 5 plus 5 equals 0. So same. So this 0.01 actually goes to negative to 0. So just the same, okay? So let's now discuss about the properties of that graph, okay? So we know that the domain here will always be real numbers because you can extend the graph in both directions, okay? The set of all x such that x is an element of real number, okay? And for the range, as you can see, the graph is confined below y equals 5. So the range is the set of all y's such that y is an element of real number where y is less than 5. It can't be equal to 5 because that's your horizontal asymptote, okay? As for the end behaviors, as x approaches infinity, look at the graph. The graph is approaching positive 5, right? So f of x approaches 5, and the other one, as x approaches negative infinity, as you can see, the graph is decreasing. So f of x approaches negative infinity. And for the interval, as you can see, from left to right, it's increasing, right? So from negative infinity to positive infinity, the graph is increasing. There. Thank you.